I am going to be talking about the special right triangles, two of them specifically, and why their lengths are their lengths. So the first one I'm going to be talking about is the 30, 60, 90 right triangle. So the reason why the 30, 60, 90, this being 60, this being 30, I'm going to talk about why each length is what it is. So first off, like I said in the first video, when you duplicate this over, this is going to be an equilateral triangle. This being 60, these all being the same. And because of all these angles being the same, that means these lengths are also going to be the same. So that means all these lengths are all the same. And I am going to label them C. So all of these are C. Well, when we cut this in half, specifically this length, it's going to be also cut in half, which we can say is divided by 2. So now to redraw the triangle, we have C over 2, and then now we have this unknown length, B. Well, in Pythagorean theorem, right, we know that C squared, or the hypotenuse, is equal or minus one of the legs squared, which we know C over 2, and this is all squared. Well, we know that's going to be equal to B squared, because C minus A equals B, squared, squared, squared. Hypotenuse minus one leg equals the other leg. And that's what this is. We're saying that this is A, that is C, and we're solving for B. Now, when we distribute the squared, it's going to be C squared minus C squared over 2 to the 2. Well, 2 to the 2 is really 4. So what we really have is C squared minus C squared over 4 equals B squared. Well, these are like terms. This is basically 1/4 C squared, and we can rewrite this as 4 over 4, because that would simplify back to 1, minus 1 over 4 C squared. And since now they're the same base, we can subtract, and now we would have 3C squared over 4 equals B squared. Now, we're going to square root one side, square root the other, and we have square root of 3, this is all simplified by the way, C over, or this will be, square root 4, and what this is really just square root 3C over 2 is equal to B. Well, this C over 2, that's the same as up here and up here, right? So if we label this equal to A, then this would also be A, and this would be A square root 3 equals B. And we know that. We know that when you have the short leg, you just multiply the square root of 3, and that's where you get the square root of 3 originally from. So if we were to put random lengths for these, and we say the hypotenuse of this triangle is 1, well, because of C divided by 2, we know this is going to be 1/2, and because of A times the square root of 3, we know that it's going to be 1 over 2 times the square root of 3, or square root 3 over 2. And that is how you get the first special triangle, and that's how you find all its lengths. Now, we are going to go on to the second one. The second one being the 45, 45, 90. Well, when we make this triangle, we know that this angle is 45, this angle is 45, which means that these two are also going to be the same lengths. This being the hypotenuse. Well, back to our Pythagorean theorem, we know that this is C, we'll say this is A, and this is B. Okay? Now, with A and B, since we know that A is equal to B, we can write that out. A is equal to B, which means that A squared is equal to B squared. Now, this is going to come in handy when we know, or since we know the Pythagorean theorem is A squared plus B squared is equal to C squared. Well, if A squared equals B squared, well, we can just substitute one of these in, and I'm going to choose A. So now we have A squared plus A squared equals C squared. Combining like terms, this becomes 2A squared equals C squared. And then again, what we did in the other one, square root everything. We have the square root of 2 times A equals C. And we know this. We know that when you have this length, you're going to multiply it by the square root of 2 to get to this. And if we have points, we'll say that this, the hypotenuse, is 1. Well, if this is multiplication, then we just divide by the square root of 2 to solve for A, which means A equals C over square root 2. So if we apply that here, we have 1 divided by the square root of 2. And because both of these are the same, we know that both of them are going to be square root of 2, or 1 over square root of 2. But because this is a square root, we have to rationalize it. So that means that we're going to have to multiply by the square root of 2 on the bottom and the top for both of these. The square root of 2 times the square root of 2 is going to be 2 over 1 times the square root of 2 is going to be just the square root of 2. So now we have square root of 2 over 2. And that's for both this length and this length. And that is why when you have the hypotenuse of 1 on a 45-45, this length will always be square root of 2 over 2, and this length will be the same.